Information security has grown to be a colossal factor, especially with modern communication networks, leaving loopholes that could be leveraged to devastating effects. To mitigate this vulnerability, cryptography is used, and in this lesson we will specifically be discussing symmetric and asymmetric cryptography. Before we continue, let's make sure we are clear on a few key terms and concepts. First, let's discuss algorithms. An algorithm is basically a procedure or a formula for solving a data snooping problem. An encryption algorithm is a set of mathematical procedure for performing encryption on data. Through the use of such an algorithm, information is made in the ciphertext and requires the use of a key to transforming the data into its original form. This brings us to the concept of cryptography that has been long used in information security and communication systems. Cryptography is a method of using advanced mathematical principles in storing and transmitting data in a particular form so that only those whom it is intended can read and process it. Encryption is a key concept in cryptography. It is a process whereby a message is encoded in a format that cannot be read or understood by an eavesdropper. The technique is old and was first used by Caesar to encrypt his messages using Caesar cipher. A plain text from a user can be encrypted to ciphertext, then sent through a communication channel, and no eavesdrop can interfere with the plain text. When it reaches the receiver end, the ciphertext is decrypted to the original plain text. Let's familiarize ourselves with a few more key terms. Encryption. Encryption is the process of locking up information using cryptography. Information that has been locked this way is encrypted. Decryption. The process of unlocking encrypted information using cryptographic techniques is called decryption. Key. A secret, like a password used to encrypt and decrypt information. There are a few different types of keys used in cryptography. At a rudimentary level, symmetry is the quality of being made up of exactly similar parts facing each other or around an axis. In cryptography, when we discuss symmetry, we are referring to keys rather than shapes. There are two categories of encryption algorithms: symmetric algorithms, which are encryption and decryption operations using the same key, and asymmetric algorithms, which is encryption and decryption operations that use different keys. We will first discuss symmetric encryption. This is the simplest kind of encryption that involves only one secret key to cipher and decipher information. Symmetrical encryption is an old and best-known technique. It uses a secret key that can either be a number, a word, or a string of random letters. It is blended with plain text of a message to change the content in a particular way. The sender and the recipient should know the secret key that is used to encrypt and decrypt all the messages. Blowfish, AES, RC4, DES, RC5, and RC6 are all examples of symmetric encryption. The most widely used symmetric encryption algorithm is AES-128, AES-192, and AES-256. The main disadvantage of the symmetric key encryption is that all parties involved have to exchange the key used to encrypt the data before they can decrypt it. Symmetric encryption does provide some unique challenges, however. Let's say that Alice and Bob want to communicate with each other. If they both know the same shared secret, they can use it to exchange encrypted messages with each other. This works great when we only have two people involved. They can simply agree on an encryption key and then use it to communicate with each other. If we have three people involved, now we need to change things up a little bit. Alice and Bob can still use the shared secret key to communicate with each other privately. But now Charlie joins the picture and wants to be able to communicate with Alice and Bob. Each person in the group wants the ability to communicate privately with the other member of the group. Alice already has a way to communicate privately with Bob, but then we need to add a second key that allows her to communicate privately with Charlie. And we still have a missing link here. Bob and Charlie don't have a way to communicate privately. We have to add a third key that allows those two to communicate with each other. So for these three people to communicate privately using symmetric cryptography, we need three keys. As groups get larger, we need more and more keys to facilitate this communication. Therefore, the challenge of symmetric cryptography is that the larger the group gets, the more symmetric keys you'll need. And that can be expressed in terms of this formula here: n, open bracket, n minus 1, close bracket, divided by 2. This challenge is thereby alleviated with asymmetric encryption. With asymmetric encryption, there are essentially two keys: a private key, which is held in secret by the user and not disclosed by anyone else, and a public key. A public key is freely distributed to everyone with whom the user would like to communicate. Asymmetrical encryption is also known as public key cryptography, which is a relatively new method compared to symmetric encryption. Asymmetrical encryption is also known as public key cryptography, which is a relatively new method compared to symmetric encryption. Asymmetric encryption uses two keys to encrypt a plain text. Secret keys are exchanged over the internet or a large network. It ensures that malicious persons do not misuse the keys. It is important to note that anyone with a secret key can decrypt the message, and this is why asymmetrical encryption uses two related keys to boosting security. A public key is made freely available to anyone who might want to send you a message. The second private key is kept a secret so that you can only know. A message that is encrypted using a public key can only be decrypted using a private key, while also a message encrypted using a private key can be decrypted using a public key. Security of a public key is not required because it is publicly available and can be passed over the internet. Asymmetric key has far better power in ensuring security of information transmitted during communication. Asymmetric encryption is mostly used in day-to-day communication channels, especially over the internet. Popular asymmetric key encryption algorithm includes RSA, DSA, and elliptic curve techniques.